basketball.
Lots of running. And not much basketball.
No basketball
Zero
either.
basketball.
Zero basketball.
There was one basketball. No basketball playing.
No losses? No losses?
Alright, question
Potatoes with potatoes.
2. Alright, so basically how this
Are those
works
potatoes
is,
or lemon?
so you have a number n is at least
Right,
3.
Maybe project 4. Project
There's a
6.
bait in there, I guess, maybe.
Wait, there might be a bit.
Small bait, it's not that bad.
Dang it.
Wait.
And you have,
Maybe I got bait.
yep,
Oh yeah, it's this one. Yes.
you have 2n minus 1 points on your circle.
Ooh, what is going on here?
And then they ask, you can't K of them black?
Oh, racist.
Yes, sir. Separate.
Color them red.
And then it's asked, so what's the minimum K? Such that for any configuration, for any,
Slightly same
there are two black points who contain that such that one of their arcs the arcs excluding them contain exactly n points.
Oh wait, this gives me flashbacks to the last week's question.
gas
What?
station.
Gas station, I know.
Yeah.
That's why I
2n minus 1.
Alright, so you just pick, I guess you pick like n equals to 3. So n equals 3, you have
5 points.
5 points.
25.
2n minus 1. And such that 2, you have to pick points, and then you want it that no arc has 3 points. So how would you pick this?
No, you need another point.
And then
You
another
need
point.
3 points.
Yes.
And then another
And then another point. And basically for there to be 3, you just need like 2 of them to be next to each other, right? So
Yes.
if you have 3 things, you always have one next to each other, so k equals 3.
Mm-hmm.
Oh,
Okay.
it's 3. Oh, it's 3 strictly inside, right?
So you want like this thing to have 3, yeah. So if n equals to 4.
Okay. This...
3,
Right.
4, 5, 6, 7.
Sorry, this is a not hard question.
Pick this one, and you need it to be 4.
Yeah,
4 points.
4 for this one.
So basically, you need to be like, if you have any that's two around it across each other, then you're done.
And you can do the one that's like diametrically opposed almost. So the one
Yep.
on the bottom,
This one.
and then the one adjacent to it. Yes, the one adjacent to the original one.
Which one? Either side doesn't matter.
Yeah,
Or
it
which side do you want? I think you have to do this side, right?
Yeah, you have to do that.
Yeah.
Side, yeah.
Okay.
Wait,
And then
so,
now you have
so no two things can be 2 apart. Or-
Yeah, no 2 things can be 2 apart. Yeah.
Oh.
What is K again? Just
Number of black
No,
mark
like
points.
what can K be?
K can be any number. Like what it's asking for, what the minimum K is, such that.
Oh,
Yeah. Okay. So 3 of them is fine, and then if you have 4 of them, something bad potentially definitely happens in this case. Other case, can you get less than 4, or like is there a way to put 4?
high key down. High key
I
down.
don't think
But
so. 'Cause
people-
every time you place one, you cross one out. Well, you cross 2 out every time.
Oh,
Okay.
yeah.
So every time you pick, I don't know, you pick this one, then
You cross.
these 2 get crossed.
Yeah, and then you go from the crosses to minimize the number of each of crosses.
Yeah. So I guess it's like the way you would think about it is you can kind of count.
Yeah, let's count.
So if there's 2n minus 1, you're kind of... So it's like your thing, and then you got 2 points. And if you have n here, you have n things here, and there's 1 and 2 here. That's n minus 2 things, so there's n minus... There's going to be n minus 3 objects here.
Yeah.
So every time you kind of just go like from here, you go... Well, you go like n plus 1 across, right?
Mhm.
And you can just... If you kind of just pair them up that way, what happens? So
Yeah.
like... So
if you
1,
go
1, and then 2, 3. So you need n plus 1 across, so you need 5 across. 1, 2, 3, 4, 5. So 2. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5, 5,
what, 5?
6. 4. I can count 4.
Yeah.
1, 2,
Not
3, 4,
count.
5.
Every time you
Oh, it's a graph.
6.
you
and
take
7.
each
1,
black
2, 3,
point
4,
and
5.
then you
So 7.
go across and mark the other one as not black.
So and then tell me like where does 7 after you reach the 7th point, where does it go? Back to 1. So what happens is like 1, 2, 3, 4, 5, 6, 7.
Then you just
And-
need to pick non-consecutive, right?
Yeah, so every time you pick one,
Yeah, it gets rid of.
it gets rid of like the consecutive ones. Or rather, another way you can think of it is the way I thought of it was if you have the pairs like 1, 2, 2, 3, 3, 4, 4, 5, 5, 5, 6, 6, 7, and 7, 1. And every time you pick a, and basically if there's 2 in any if there's 2 in any one box, then you're forced to go back.
Phrase it so like 7 points on the circle and mark to it.
Yeah.
You can just change like the n to like 0.
Yeah. So the way, yeah. Alright. But well, okay. So what should you suspect the answer to be?
Oh, K equals N. Whoa.
So
It's like
there are like 2n minus 1 things, and you can't have consecutive. Can't have two consecutive.
yeah. And there's special cases.
So then you can do n minus 1. So in order to always have 2 consecutive, you need n, right?
Yeah.
Okay. So let's just. Okay, we're gonna check that. We're gonna just keep
no.
testing, right? So just
Yes, keep doing small cases.
we're just gonna make sure, right? Okay.
Yeah, and n equals 5 is a special case.
Okay, well you
Okay.
can use like
First special case.
oh it's like when it's a multiple.
Yeah.
8, 9.
So when it's
10,
a multiple of like
oops,
3, I'm pretty sure. Because then it.
Wait, hold on.
When the number of
It's
points in
like
a circle is a multiple.
Yeah, exactly.
Alright, so we have 9 points on the circle. So now we go 1,
9-point circle.
and then we go.
9 points.
So we will go around n plus 1. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 3. 1, 2, 3, 4, 5, 6. Oh wait.
Oh
no.
Oh no.
Okay, now this gets interesting.
Yeah, I made a bit of a mistake. Blunder.
Yeah, you have to get through this, and then now it's
You just need a case dash constantly.
now it's just like
So
it's like that. Just divide
Yeah, so
by
there's
3.
just 3 groups of 3.
You divide by 3, and then you do that with the
And then
and
and then the group it just kills the other 2 in the group.
yeah, so
So the answer is 4 for this case. I'm pretty sure it's n minus 1.
it is. I don't think it's. I don't know. It might be n minus 1, but we'll see.
We will
It's just
see.
N minus
It is n minus 1.
I'm not sure if it is. It might be.
Oh yeah.
Depends on
these
if it
are
counts to.
algebra.
Okay.
I know it's 1 but
So
I forgot the algebra I did. Let me
you got 3. So now there's a problem when n equals 5. So there's like 3 of them, because it now splits into groups of 3. So it's 4. 5 and 6.
It's more complicated than I thought.
Yeah.
Oh, no.
So now you got like 3 groups of
Oh, no.
3. So instead, and in each one, so 3 groups of 3. And in each one, you can only have, and again, it's kind of the same in the sense that you still can't have like consecutive stuff. So in that case, it's going to be, I guess it's going to be like 1 in each group, 1 in each group.
Oh, it's a a fractal-like pattern. I don't know.
and then plus 1.
Ah.
So it's going to be, for n equals 5, k equals to 4. Okay, so now we stumbled across a potential issue that could occur. Now the question is like, so you'd suspect that usually this issue does not occur. For example, if you try the next case, n equals 6, then there's 11 points. It's not going to happen. Nothing bad's going to happen.
11.
So when does the issue occur? I guess. Is the question.
Like 2n minus 1 and they're not.
GCD of the numbers.
So 2n minus 1.
They are not.
And the other what like so if you think about it, you're going across n plus 1, right? So you're going every time it's like on. So you have to go like n plus 1 objects. So it's like and n plus 1. So GCD of n plus of these two things does not equal to 1. Then a problem happens.
The number of cycles is odd because you can't because every cycle is the same size. I mean, the size of each cycle is odd.
Yes. So when this is not 1, then a problem occurs. Luckily for us, this doesn't occur too often.
Yay. When does this occur?
So
We can do it's the same as the GCD of it's the same as the GCD of 3n and n plus 1.
so yeah. So the problem here is, can anyone tell me what to do with this?
We cry.
Bro, it's like
Oh, it's just 3.
Euclid.
It's 3, right? So it's
Euclid. Okay, so it's like this is actually equal to GCD of 2n minus 1, and you do it like 2n plus 1 minus 2n minus 1, which is actually just GCD of 2n minus 1 and 3.
Oh wait, no, it's not that hard.
Bruh.
It's not that hard.
Yeah, okay. So with this in mind, you can just do
Okay. Therefore GCD equals 3.
so when 2n minus 1 with 3 divides 2n minus 1, it's special. We have a special case.
Oh no, Michael. That's just when n is 2 mod 3, right?
Yes.
Yeah, exactly.
So for everything else, we know that it's supposed to.
It's n.
Everything else is n. Everything else
Is n.
k equals to n, and then for this case, it should be so. You divide it into 3 groups, right? So 2n minus 1 over 3 groups, and in each one, you have less than half of the numbers, so it's going to be the like this on 2 and the floor of this, right? And then, but you can have like that's in each cycle, so you can times this by 3, and then you get a plus 1, which is 3 times 2n plus minus 1 on 6 plus 1.
Is that the answer?
Yes.
Okay. Wow. Amazing.
And it might be n minus 1. It could be. It probably is. I trust that reasonably.
Thank you.
Anyone believe it?
Yeah.
Yeah, sure.
Sure.
Yeah, sure.
Oh yeah, because that the top thing is odd, so that means
Yes.
like it's half, so you have to subtract half.
But you also got this add 1 over here, so who knows?
Like 2n minus 1.
But anyways, I'm sure you could leave this as here and just stop there.
Alright. Oh yeah, I think it is n minus 1.
Alright. So
Oh, wait, okay, whatever.
for when 3 divides 2n minus 1. Okay, so that is the answer. That is question 2.